That top identity. Yeah. I don't have any packets with me today. I do have some up in my office if you want to get them like afterwards. If you have your own paper, like today's not a bad day to be without a packet, because all that's written in the packet is that, and then the same on the next page. It's like you have to write like 3 extra sentences. So there's the thing we want to prove. How would you like to go about proving that? Start with one side and simplify, or walk with both sides and do stuff on both sides? Pick one side and simplify? Walk with both sides at the same time. I think that's a reasonable choice here because, well, let's just see what people want to do. So we're going to walk with both sides. What would you like to do first? So I think the way to decide is there something you could do to both sides of the equation that would simplify this equation? Or if not that, then rewrite everything in terms of sine and cosine and see what happens. Is there something you see that would like simplify this before we rewrite? Well, I see like some complicated stuff in a fraction. Do I need to see complicated stuff in a fraction? What could I do to get that complicated stuff to not be in a fraction? In the denominator of a fraction? Multiply it to the other side? Yeah, and the fancy word for that is cross-multiplying. So let us begin by cross-multiplying. By cross-multiplying, we get 1 plus tangent psi, and I don't know if I've used that letter before. That's the Greek letter psi. That's not important, but 1 plus tangent is equal to tangent psi 1 plus cotangent psi. All right. Did I cross multiply correctly? I just moved the denominator to the other side. I put parentheses around it to make sure I multiply by the whole thing instead of just the 1. All right. So now that we've done that, follow your nose. You see this equation, you want to simplify it. What do you do? Great. Let's rewrite it as sine and cosine. So let's rewrite in terms of sine and cosine. So let's see. That will give me 1 is still 1 plus what's tangent of psi? Sine over cosine. Tangent again, so that's another sine over cosine. 1 is still 1 plus what's cotangent? Cosine over sine. All right, so we're plugging along. That's how far we've made it so far. And we continue to ask the same question. Now that we've done that, what seems like a reasonable thing to do next? Don't worry about if like the thing that your instinct is telling you is definitely the right thing. Because it doesn't matter if you do like there's no the right thing. Right, we could have done those 2 steps in the opposite order and gotten to the same place. So don't worry about like if the thing you're going to suggest is like, obviously the right thing. We'll just try it. What would you like to do to this next? Yeah, like I see a thing times some stuff in parentheses. Let's multiply it out using the distributive law. So let's see, using the distributive law on the right hand side. So the left hand side, I guess, is staying the exact same. We got 1 plus sine psi over cosine psi equals, distribute this over. Thing times 1 is the thing, sine psi over cosine psi, plus sine psi over cosine psi times cosine psi over sine psi. Did I distribute correctly? Cool. What next? What just seems like something reasonable to do? So if you just saw this equation and I just told you simplify this as much as you can. Is there a simplification? Yeah.
With stuff multiplied, it's just a little more.
Yeah. I see like the same thing in the numerator and denominator. So let's write down, in fact, basically exactly what you said. Let's use that sine psi over cosine psi times cosine psi over sine psi equals 1. Because it does. So what do I wind up with? 1 plus sine psi over cosine psi equals sine psi over cosine psi plus 1. All right, and I'm painting myself into a bit of a corner, so hopefully it's at least close to done now. So, either do you see something that would just simplify this equation, or do you see a way to convince me that this equation is true? Yeah.
Well, if you subtract one side over the other, it's just 0 equals 0.
Yeah, cool. So maybe I'll even not subtract things over. I'll just say I see the exact same thing on the left and right hand side. Up to commutativity, but addition is commutative. Since addition commutes, this is a true identity. So we are done. Because this bit of algebra gives you a path to simplify this equation that we started with to something that's obviously true, which means that the equation we started with must have been true as well. Cool. So, when you're proving a trig identity, this is exactly a path to follow. Start thinking about what would simplify the equation you're trying to prove, or just simplifies the more complicated side of the equation you're trying to prove. Keep on going until you have something that's obviously true. Once you have that, you're done. So, I think this next one, item 8, I think is one that I just want you to do. So I think I'm going to be quiet for a bit. And remember, when I ask people if they have people that they would be willing to walk with, they said yes. So if you have people around you you're willing to walk with, collaborate on this. So the mindset to have is don't worry that like you're making the correct step, because there's no the correct step. As long as you make like a correct algebraic manipulation, then, and you simplify the thing, eventually the goal is that you'll wind up with something that is just, it's true. So, as you're going through, if you're feeling particularly stuck, you want me to come around and maybe suggest a step to you, raise your hand and I'll come around. Alright, so I guess in the last step you like cotangent is 1 over tangent. Yeah. Maybe I'd like the sentence. Like distributed 1 over and tangent 1 over 1. Cotangent is 1 over. Yeah. In fact, the proof you follow is probably the better one because it's simple and feels like similar. Yeah. Alright. Let's see. So you do it across the side, something like that. So on this side, I see a fraction plus a fraction. And there's like a thing you should always think of when you see a fraction plus a fraction. Have you read fractions? You need a common denominator. So there's an idea. So try going through the steps on the left-hand side to get a common denominator and add those fractions and see what happens. Is that okay? Oh, sure. Yeah, so so don't worry, so the idea here is just, here's an identity which algebra should simplify that, it just be something that's obviously true. And so a bit of algebra you see to simplify this is I see a fraction, so fractions get a common denominator. When you look just at that side, what is that common denominator? Cosine times sine? Oh, yeah. Yeah, so let's do that. So what you had was and I think the common denominator should be cosine times sine. What does this become when you get that common denominator? Say that again? I think it'll be sine squared on top. Because I want the denominator to be sine times cosine. So the top will be sine squared. Yeah, it's not good. So, the stuff you proposed so far was get things just in terms of sines and cosines. So in terms of sine and cosine, this becomes sine over cosine plus cosine over sine equals 1 over cosine times 1 over sine. And on this side, I see a fraction plus a fraction, so let's get the common denominator. So the common denominator is going to be cosine times sine. So it looks like the first bit I have to multiply and divide by cosine. Nope, I have to multiply and divide the first side by sine in order to get the denominator to be sine times cosine. So sine z over sine z times sine z over cosine z plus, next bit I need to get a sine times cosine in the denominator, so I think I want to multiply and divide by cosine. And I've left the right-hand side open. So, I guess the first thing to worry about is, are those two equations, like, obviously the same equation? Yeah, just like I've multiplied some of the terms by 1. And the whole reason to get a common denominator is to add the fractions. Let's add those fractions. Well, you agreed with me even though there was a typo. That should have been a sine z, shouldn't it? Cosine divided by sine became that cosine divided by sine, multiplied by cosine over cosine. So, now that you have a common denominator, you can add fractions. So the common denominator is sine z cosine z. Numerator is sine times sine, which is sine squared. Cosine times cosine. And this is allegedly equal to 1 over cosine times sine. So there's just like, I guess I transitioned from people walking independently to talking through something. But people followed a path roughly like that so far. Cool. Maybe you did some of the steps in a different order. So now that you see this, so what have we done? We've started with the equation we want to prove. We simplified it. Well, I guess that makes it more complicated looking. Then we got a common denominator, made it more complicated looking yet, and then combined some fractions. What step might seem useful next? So either you can do something to both sides of the equation to simplify it, or use some other fact that you already know to simplify it.
I agree on that.
Yeah, I see a sine squared plus cosine squared. And I know what sine squared plus cosine squared is. By the Pythagorean identity, sine squared plus cosine squared is always 1. Oh, yeah. Thank you. And I'm going to do something which I would not like to see in your like actual write-up. I'm just going to like split the paper with a line and go to the side. That's totally an artifact of just I have not respected the space that I gave myself. You know, if this is your homework, then just go to the next page. So let's do that. So by Pythagorean identity, sine squared plus cosine squared is always 1. So this is going to become 1 over sine z cosine z equals 1 over cosine z sine z. And your goal is to simplify down until it becomes something that's just already something that you know is true. Is this something that you can just tell me why it's true in one sentence or something? Cool. What's that sentence? Why is that last equation true? It's like just the same thing on both sides of the equal sign? Yeah, maybe up to commutativity. I think this sine and cosine are in the opposite order. That's not a big deal. And this last equation is an identity by commutativity. Neato. So your goal in trying to prove any sort of identity, one good way to prove an identity is just do algebra to both sides of that identity in hopes of getting down to something you just already know is true. There's the plan of attack we just followed. Did anyone do stuff that was like significantly different from this? I mean, you could have. How many people like took one side that they decided was more complicated and just simplified that one side? Oh, well, I mean, you could have. In fact, I think most of what we did was just that. This step only happens on the left-hand side. The next step only happens on the left-hand side. In fact, everything only happens on the left-hand side. I think in reality, what we should now do is just rewrite this to manipulate the one side. So I don't have space here. Maybe I'll go to the bottom now that we have a proof written. Well, maybe here's a question. How many people usually in this class, when they do the homework, really like do the homework twice? Once they do it to get like a rough draft to work out the ideas, and then they write it out in a clean copy that a human being can read? That's a good thing to do. Both because it like makes you actually learn the material better, and also because like I need to be able to read it to grade it. Let's do exactly that on this one. Now that we see a better proof, everything only happens on the one side. Let's rewrite it using that idea. So here's a revision. Let's start with the side that's more complicated. And it looks like I'm going to use the exact same steps. First, we rewrote in terms of sine and cosine. Let's do that. The next step, we've got a common denominator. And a lot of times, like, if you're getting a common denominator, you know what the next step's going to be anyway. It's going to be add those fractions. So especially if you're doing like the second go around, you can combine those two steps into one. And the next step was, this is equal to 1 by the Pythagorean identity. And I guess the last step is where I want secants and cosecants to show up, so let's rewrite in terms of secant and cosecant. Is this basically the same proof as was already written? Yeah, but it just takes advantage of the fact that we already know we only need to use one side, so let's only use one side. Ruby. So, let's carry on. Let's go to the next page. I think in the interest of hitting an idea that we haven't hit yet, I'm going to jump down to item 10. So, you know how, like, when you're proving a trig identity, a lot of times you use the fact that you just know that the Pythagorean identity is true? You can do the same thing with any other identity. If there's any other identity that you know is true because, say, you've already proven that identity, you can use that. If there's something that you've already proven, you can use that in a later proof. So let's jump down to that item 10. There's an identity that I would like to prove. Tangent plus cotangent divided by secant times cosecant. So with that, I'm going to leave that up. Look back at item 8, which we just finished proving. So item 8 tells us that two things are equal. Do one of those two things just show up verbatim in this problem? It does, right? Like, the numerator of this fraction is exactly one of the two sides of item 8. So here's what this problem is trying to communicate. I can make this proof super short by appealing to something I already know. Let's appeal to this thing I already know. So let's start with this. By item 8, I know that tangent alpha plus cotangent alpha is equal to something. What does item 8 tell me tangent plus cotangent is equal to?
The denominator.
Oh, okay. Yeah, that's excellent. Yeah. Saying it that way even tells me what the next step's going to be, right? So let's use this item 8 to just do that. So tangent alpha plus cotangent alpha divided by secant alpha cosecant alpha. Cool. So once you already know that an equation is true, you can use it. I know that the old numerator is the same as the new numerator, so I can do that. And now I see the numerator and denominator is the same by your observation. So what should I do next?
Since they're both equal to each other, it just comes down to it already is one.
Anything?
You can just imagine it's an imaginary vector that is equal to the other vector. Like you can just plug it in.
Yeah, because anything divided by itself is 1. So I see a thing divided by itself. I guess I don't like the word imaginary.
Yeah, I try to change it because that's already a thing.
Yeah. It did. Yeah. It's yeah. Just drop the word imaginary. A number divided by itself. So this reveals that tangent alpha plus cotangent alpha divided by secant alpha cosecant alpha is 1. Oh, cool. That's exactly what I wanted to prove. And maybe another thing to notice, with that observation, there was more effort spent in just writing it than coming up with the idea. Once you know that, oh, I see the same thing in the top and bottom, it's obviously one, you just got to put that into words. This isn't the only way to do it. Yeah, people feel pretty good? So I think with my remaining 4 minutes, I will propose one of two paths. We can talk through one last identity. Sine times tangent is equal to secant minus cosine. Or, if you look at this last page, there's an extra credit. So maybe I'll point this out. Is there anything special about, like, trig functions in the idea of proving identities? I mean, I guess some. There are facts you know about trig functions, but there are facts you know about other functions too. Here are 3 equations that I claim are identities. So no matter what you plug into these equations, they'll always be true. As an extra credit, I'll have you convince me of that. So maybe I'll see what people want. With the remaining 3 minutes, how many people would like to talk through one last identity together? Cool. Those of you who now don't want to listen, maybe focus on one of those. It's an extra credit to get them done. Let's try to prove this last identity. Sine times tangent is equal to secant minus cosine. And let's just see what people think. What seems like a good first step if I want to convince myself that that equation is always true? Let's start with this question. Is there one side that's obviously more complicated than the other that I might take advantage of? Not really. So let's use both sides of it. Is there any obvious simplification to make before we rewrite in terms of sine and cosine? I don't see any. So let's just rewrite in terms of sine and cosine and go from there. So let's rewrite via sine and cosine. Sine x is still sine x. Tangent x becomes sine x over cosine x. Secant x is 1 over cosine x. Cosine x is cosine x. Cool. What do you see now? Does the left-hand side have any obvious simplification?
Should you get rid of the cos x at the bottom of the denominator?
Oh, cool. How would you do that?
Multiply to the next line.
Awesome. So let's cross-multiply by that cosine x. Let's multiply both sides by cosine x. That'll leave me with sine squared x is equal to cosine x times 1 over cosine x minus cosine x. And sine times sine is sine squared. I don't think that means writing down as a step. Okay, what next? Don't worry about if the thing you want to do is like the right thing to do. As long as it's an algebraically correct thing, it's progress. What would you like to do to this next? Let's distribute. And I think I don't have enough time to write down any more words. Cosine times 1 over cosine is 1 minus cosine squared x. Cool. What next? Oh, that's the Pythagorean identity, so we're done. So the last sentence is going to be, by the Pythagorean identity, I know that that equation is true already. So I'm done. You know, people feel pretty good about the idea of proving trig identities? Nice. Then, take a look at the open-ended. You will prove a few trig identities and write down some things. Make sure that what you clone in is something that you would feel comfortable expecting someone else to read and understand. Because I need to be able to read and understand what you've written to grade. Okay.
So,
But you said swim?
yeah.
Okay. University?
Yeah.
Okay. Your coach is supposed to have sent me a note about this.
Okay. Sure, I can get it one time off.
Yeah, yeah. And like, then just send it to me because like, one should do this the right way, and like, I think a lot of the athletics department is really bad about doing this the right way. So I saw you cut in the middle.
No, it's fine.
And then, what I'll do is, at about the same time as the like group event happens, I'll put into Canvas the what the group thing is, and then I'll just do it on your own.
Okay.
Yep. And I'll set a deadline. It'll probably be a week after the event. So it's gonna be less than that.
Do you have my exam?
Did I not call your name? What? No, remind me your name. Yeah, sure. I swear I gave you yours. Like, when you here on like, you were here on like the Monday before Thanksgiving, right? What?
I was.
Yeah, I handed it to you then.
Really?
I am pretty sure. Like, go through your records, and if like, I'll go through what I have, but I'm pretty sure I gave you yours. I'm like, and if I didn't, then like, shoot me an email and say I don't have it, and we'll figure out what to do about it. I'd feel really bad if I just lost your exam, but.
Can I get the chapter 9 notes?
Do you mind going upstairs?
Yeah, I can do that.
Yeah, let's head upstairs. Let me hit this button.